That was kind of eerie sounding. I don't know what in the world I was playing on that. Okay, just goofing around. Seeing if I can come up with anything cool. All right, so speaking of something cool, it would be this last part of this section. Okay, so a lot of this stuff has to do with using the calculator, and a little bit maybe a quadratic formula might show up and a few things like that. So you don't always use the unit circle. In fact, in practice, most of the time, you're away from the unit circle and you're using technology a lot. So these kind of problems, what we're going to do is actually use our technology and use our calculator most of the time. All right, so to begin with, there's no place on the unit circle with the basic special angles where the sine is 0.35. There is a place on the unit circle when that happens. It's an angle that you would have to find using technology. Okay, back in the old days, you had to kind of use tables and do what's called an interpolating and stuff like that. Nowadays, we use technology. So really the idea on this is we're going to use a calculator to find all real number solutions. So that means what we're going to do is we're going to find a formula. All right. And to begin with on this, really what we need to do is on our calculator, we're going to need to make sure that we're in radian mode to begin with. And we're basically going to do this. All right, so all I'm going to actually do is just x. I'm going to go to my calculator and I'm going to do the inverse sine of 0.35, and we're going to get answers in radian mode. And we're going to get a reference angle on this when we do this. So I'm going to go inverse sine 0.35, and that will give us a reference angle, all right, which is in quadrant 1. As I'm doing some of these things, I'm going to kind of slide over the details that I got on the calculator. I don't really need the unit circle too much on this. Okay, so I got that. So what I want to do is help you to realize that in a problem like this, this is only a reference angle, so you have to understand a couple things. Okay, this is quadrant 1. That's a quadrant 1 reference angle of 0.35 radians. Okay, how do I know that? Well, because this is a positive number. Remember, the sine is positive in quadrants 1 and quadrants 2. So I've got my quadrant 1 answer. That's what came out on the calculator. But I also have a quadrant 2 answer, which will have the same radian reference angle. So what I'm going to end up doing on this problem is I'm going to get two answers. The first answer is 0.35 radians. That's kind of weird coincidence that it turned out that way. So actually, I probably should round that to 0.36. Okay, I'll just round these to I'd say round to 1 decimal. Let's do 2 decimals. So the quadrant 1 angle is 0.36 radians. And then the quadrant 2 angle, what we have to do is we have to go all the way halfway around the circle, pi, less that reference angle. So we got to do pi minus 0.36. And again, I can do that on the calculator. Okay, so I will go pi minus 0.36. And then that will give me another one. I'll just round this one off to 2 decimals also. So the quadrant 2 angle is going to be approximately 2.78 radians. Okay? Now what we're supposed to do is find all real number solutions. So what we're going to do is we're going to write a formula for this. It's pretty analogous to what we did in the last section. So I'm going to say set of x. The first answer is going to be 0.36 plus 1 lap around the circle is 2 pi k. And of course that's in radians. And then we would also have x equals about 2.78 radians plus 2 pi k, and then we'd have to say that k is an integer. Okay, so that would be how you would write the solution to that problem, is like that. Okay, the calculator gives a reference angle. That's kind of the key when you're putting this together. And this is pi, halfway around the circle, minus the reference angle gives that. Okay, so actually, if you were kind of trying to make sense out of this, you could do this graphically, but you could also do this. If you just take the sine of 0.36 radians, we're going to get about 0.35. And if we were to do the sine of 2.78, we would also get about the same answer. Okay, we're rounding, so that's why we're off a little bit. So that's how you could tell that you have the right answer to the problem, is like that. You could even do this. You could do the sine of 0.36 plus 2 pi, and you would still get about 0.35. Or you could go the sine of 0.36 minus 2 pi and get about the same answer like this. So this formula is generating approximate answers. That's the idea. Okay, so that's what you would want to kind of do on that, is just do the inverse sine of that trig function. Okay, the next one we're going to do exactly the same thing. We're going to just do the tangent. Now there's a couple of things on this that you want to do. Come on, OneNote, do what you're supposed to do. There we go. Okay, so a couple of things I would start with on this problem is I would determine where I am, what quadrants I am. So the tangent is negative in two places, in quadrant 2 and quadrant 4. Okay, so we're going to go directly to the calculator, and we're going to do this like this. We're just going to go inverse tangent of negative 3.5. And we'll round this again, I guess, to 2 decimals like that. Okay, so we get this result from the calculator, all right, just to begin with. All right, so again, what I did on this is x is just the inverse tangent of negative 3.5. We're going to round that off to x is approximately negative 1.29 radians. Okay, now what that's doing is that is actually giving a quadrant 4 answer. That's the negative angle there. So that's what that's going to be, is that's negative 1.29 radians. You're also going to have a reference angle of here, and that reference angle, remember, is there, right in there, so you're going to have that. Now remember, on a tangent, really all we got to do is just get one answer and then write the general solution. Okay, so what I'm going to do is I'm going to go ahead and just get the quadrant 2 answer. The quadrant 2 answer would be halfway around the circle pi less that 1.29 radian angle. Now remember, a reference angle is positive, so that's why I'm doing that. So what I'll have on this then is this. I'll do pi minus that reference angle of 1.29 that came out on the calculator, and that will give approximately this then. So in quadrant 2, we're going to get x is approximately 1.85 radians. Okay? Now actually all we got to do is, on a tangent, we just write the answer this way. We don't have to get both answers the way that we've learned, because the answers are pi radians apart. Okay? I'm just going to cut all this stuff out of here. It's getting in the way. All right, and what I'll do to get this final answer is I just do this then. I just do, say, set of x such that x is equal to about 1.85 radians plus pi k this time. And the reason is the period of the tangent. Now, why the hell did those things come back up? Okay, OneNote just drives me crazy sometimes. Okay, so we got that, and then this would be k is just some integer like that. All right, and that's it. That would be the general solution to that problem. Again, the reason we do that is because the period of the tangent is equal to pi. So it would go like that. Now, if you wanted to interpret this on a calculator, then one thing you could do is you could do this. Okay, so like if we did the tangent of our first answer, 1.85, notice that if we do that, we should get about negative 3.5. If we did the tangent of 1.85 plus the period plus pi, okay, we should get about the same thing again. Okay, and then if we did the tangent of 1.85 plus 2 pi, because we're going by integer pi's, I should get the same thing again and should get the same thing forever. So you can verify on a graphing calculator by doing that. We can tell that we have the right formulaic answer to that problem now. So you're using your calculator and you're dealing with reference angles. That's the idea. The reference angle part is the hard part for students when you do this. Okay, so I'm going to let you try the next two problems. You don't need a unit circle. You're just going to need to get your calculator out and give it your best shot and see if you can get these two put together. Okay, so let's see how we did. Again, you have to use your calculator on this. What I did on this one, the first thing is you have to understand this is a positive number, so you're asking, where is the cosine positive? And you got to remember the cosine's x over r, so it's positive where x is positive. So quadrants 1 and 4 is where that happened. Now I did all my calculations kind of over here. So I did on this, the first thing I did is in my calculator's in radian mode, I do the inverse cosine of 0.826. And that gives this answer. I decided to round this to 4 decimals. It doesn't matter if you didn't, what you round to really. If you rounded to 2 and used 0.60, that's fine. Okay, that's no big deal. So I did that, and then the quadrant 4 answer is this. It's all the way around the circle, 2 pi minus that reference angle. So you got to also get that quadrant 4 answer. So I did 2 pi minus 0.5988 and got this answer, and I rounded that off again to 4 decimals, so 0.6844 is what I did. Now I'm ready to write the solution. So I just say set of x. X is approximately 0.5988 plus 2 pi k, and it's also approximately 5.6844 plus 2 pi k. All right. Now, what I would do just to kind of verify this on the calculator is to do this. It's actually very simple to tell you right. So if you do the cosine of 0.5988, okay, notice that that's about 0.826. If I did the cosine of 5.6844, and that gives approximately the same answer. We're rounding, so it's off a little bit. And then the formula is just generating the period on this. So if you did the cosine of 0.5988 plus the 2 pi, if k was 1, you would just add 2 pi to that, and you would get about the same answer. And same thing would happen if you did the cosine of 5.6844 radians plus 2 pi. Then you would get about the same thing. Okay, so that kind of verifies it, that you're on the right track just by doing those calculations on your calculator. All right, let's see. The next one, what I did was I did the inverse cosine, or the inverse tangent of 2.9. You can see I did this on the calculator here and got about 1.2387. I decided to round it to 4. So I did that. You have to understand that the tangent's y over x, and the tangent is positive in quadrants 1 and quadrants 3. So the answer that came out of the calculator was a quadrant 1 answer. And then I got to get the quadrant 3 answer. Well, the quadrant 3 answer, I got to go pi plus that reference angle. So if you do pi plus 1.2387, you get approximately 4.3803. Now remember on the tangent, since the answers are always pi radians apart, then you don't have to worry about that next one. I want to show you what happens on this. If you take this original answer, 1.2387, and you add pi to it, which is the period of the tangent, I want you to notice what happens. You get the 4.303 anyway, see? Okay, so you don't have to go that far. So that's the answer of the problem. You just got to write that one solution like that. Okay, so the key to dealing with this is knowing how to use your calculator and knowing how the reference angles work and what quadrants you're in. Right, so let's go to the next page, and we got one more page to kind of wrap this thing up. So I'm going to do a problem with the quadratic formula, and then I'll let you kind of do the same thing. So what you would find on this one is, I think probably this thing is not going to factor. So we're going to solve this using the quadratic formula. So first of all, what we're going to do is we're going to do a trig substitution. And what we're going to do is just let, it doesn't matter what variable you use, I'm going to let, let's say p, I like p. So let's say p is equal to sine of x, so that's going to be replaced with p. And then if we square sine x, we would get sine squared x, so that's going to become p squared. So what you do is just use some variable, we call that a dummy variable. Not because it's dumb, it's just because we pick whatever we want to. All right, so what we have on this is you would have the equation 2p squared plus p minus 2 equals 0. Now that doesn't factor, so we're going to go to the quadratic formula. So the answer to the quadratic formula would be negative b plus or minus the square root b squared minus 4ac over 2a. You may need to review that because we haven't done that much in this class yet. So you may want to remember that in a quadratic equation, like the one that we're solving here, that would be a, so a would be 2. The value of b would be the coefficient of that term, so that's 1, and then the c would be negative 2. So you're always writing a quadratic equation in its standard form like that. So now we just plug everything in. So b is 1, so we're going to have negative 1 plus minus, then under the radical we'll have b squared, so that's 1 squared, 4 times a is 2, and c is negative 2, and that's going to be all over 2a, so that's 2 times 1. So again, I'm just replacing, everywhere I see an a, I put in a 2, and it just basically kind of goes like this. So a is 2, that goes here. In the formula, it just go, whoops, did I put the wrong thing in? I sure did. So it's 2a, so that would be 2 times 2. Okay, so let's just make sure I got that right. I got negative b plus or minus b squared 4ac all over 2a. So now I'm good. Okay, so I'm going to work it out. So I've got negative 1 plus minus, and 1 to the second's 1. This would be 2 negatives multiplied, so 4 times 2 is 8, 8 times 2 is 16, and that's all over 4. Okay, so I'm going to move this up here, and I get negative 1 plus or minus the square root of 17 all over 2. Now what I'm going to do on this is I'm going to get 2 answers on this, essentially is what I'm going to do. So I'm going to go back, I'm going to use my calculator, and do this. First thing I'm going to do is just do negative 1 plus root 17 over 2 and get that approximation. And I can maybe round this to a couple of decimals or something. So I'm going to go negative 1 plus square root of 17. Okay, I'm going to get that answer and then divide by 2. Okay, a good way to do this in one step is just to do this. Do parentheses negative 1 plus square root of 17, close the parenthesis, all over, and that was a 4, wasn't it? It sounded getting sloppy on this crap. Okay, so I got 4 there. I got 4 there. Let me just start this over again. I'm doing stupid things now. Okay, so that was a 4. So let me get this in the right way. So I'm going to do negative 1 plus square root of 17, get the answer, and then divide that by 4. Okay, and I'm going to round this off to, let's use 4 decimals again. So 0.7808 is what I'm going to round that off to. And then we have negative 1 minus root 17 over 4. So I need to do that. So I'm going to do this in one step on the calculator. Negative 1 minus square root of 17. Be sure you get out of that. Oh, come on. Dang it. Yeah, okay, let's try again. Okay, I have to click the mouse every time that I type something in on this computer. So I've got negative 1 minus the square root of 17. and then all over 4, and then we'll record that. Okay, so that is going to record 4 decimals, negative 1.2808. Okay, so step 2 would be to do the quadratic formula. Okay. All right, so now what I'm going to do now is these are the answers to P. So remember we had the substitution, P equals sine of x. So these things right here are the answers to P. It's not the answer to the equation. So what I'm going to do is I'm going to say sine x equals 0.7808, and I'm going to solve that equation. And then I'm also going to do sine x equals negative 1.2808, and I'm going to solve that equation. And I'm going to have to use my calculator to do this. Okay. So what I like to do on this is just kind of think about, okay, what quadrant am I in on each equation? That's real critical in these problems. So remember, this is a positive number. The sign is positive in quadrants 1 and quadrants 2. So what I'm going to do is I'm going to do the inverse. I'm going to go ahead and just do the inverse sine of 0.7808. That's going to give me a radian answer because my calculator's in radian mode. And then that'll be a reference angle that's in quadrant 1. Okay, so that's about 0.8959 is what that is. Then you're going to have the same reference angle over there. Okay, so here's what you do. Your quadrant 1 answer is done. That's 0.8959. That's an answer. Okay, your quadrant 2 answer is going to be this now. Okay, so we got to do pi less that. Halfway around the circle's pi. So we do pi minus that reference angle. And then we'll get the second answer. So we're going to crunch that out again on the calculator. Okay, so I'll do this. I'll just use my pi key. And pi minus the reference angle, 0.8959. Okay, and I'll round that to 4 decimals, so that's going to give about 2.2457. Should be right there. Okay, so that's the second answer is that. Okay, so that's 2 answers. Now we just come down here and we do the same thing. Now we have a negative value for the sign. Remember, the sign is negative in quadrants 3 and 4. So we have to get a quadrant 3 answer, and we have to get a quadrant 4 answer. Now keep in mind, the reference angle is this. So the reference angle is going to be 0.8959 in quadrant 3, and it's 0.8959 in quadrant 4. So to get your quadrant 3 answer, you need to go halfway around the circle, pi, plus that reference angle. Okay, and then that'll give you the third answer of the problem. So I say pi plus 0.8959, and then that will give another answer of the problem is going to be 4.0375 will be a third answer to that problem. Okay? All right. Now I got to do the last one. I got to do quadrant 4. Well, what are you going to do on quadrant 4? You're going to go all the way around the circle 2 pi minus that reference angle. Okay? So we need to do that. I'll do this on the calculator over here. So I do 2 pi and minus the 0.8959, and then that'll give the next answer. So that answer is going to be 5.3873. So we've got 4 answers to this problem using the calculator. So you have to understand how those reference angles work. That's kind of the whole key. I don't need the unit circle on this problem, so I had to use my calculator. Okay, so that's kind of the idea on those calculations. Now what I'm going to do is I'm just going to kind of show you how you can check your answer on this. You can do this one graphically if you want to. It's just as easy probably to do this graphically. So what I'm going to do is I'm going to clear off my graphs here, and I'm going to put in this equation. So the equation is 2. Then you got to do parentheses sine x double up on the parentheses like that, plus sine x, and then minus 2. Now, just for emphasis, I'll put 0 and y2, and then I'm going to graph this on the interval 0 to 2 pi. So you need to make sure that you're in radian mode, which I am, and then your window needs to go from 0 to 2 pi. And that's probably okay if we just do this window right here. So I'm going to slide this over here, and we're going to use that window. Now I'm going to graph and see what we get. We should have 4 answers. Notice this thing is, whoa, hold on, we may have some extraneous roots on this possibly too. Because you do get some extraneous roots sometimes when you do this. So first thing I want to do is make sure I got this in right. So I've got that okay. Okay, so I got that. It's possible I have some extraneous roots. So looks like I've got the graph in okay. I don't see any problem with that. And again, let's make sure I'm in the right mode and everything looks good there. Let's go ahead and trace out these first 2 solutions here. Then we need to see these are possibly extraneous roots, which means they just don't check. So let's trace at 0.8959, and that one seems to work. Let's also trace at 2.2457. And let's see if that works. Okay, that one certainly works. Okay, these 2 right here, though, looks like they're not going to work. So if we trace at 4.0375, that one's clearly not going to work. Okay, that's not equal to 0. And this one, you can tell, is pretty clearly not going to work either. Okay, so I'm pretty sure I got everything in the calculator right. Sometimes what will happen on these squaring problems, every now and then your answers won't check. So I don't see anything wrong with that. So it looks like we have those 2. All right. Okay, let me explain this. Now, I made a mistake on this, and I've just been so sloppy about stuff. I think I'm getting in a hurry. What I did not do right on this is this stuff right here. Okay, and I knew there was something wrong. I knew that come on. Come on, just let me erase one note, please. Okay, so I'm going to erase this right here and then show you kind of what happens here. Okay, what I forgot to do, and I wasn't even paying attention to this, I need to do the inverse sine of negative 1.2808, and you're going to get an error on that. Okay, so if I do this, I have inverse sine negative 1.2808. I hope that you know that you're going to get an error on this, because it's out of range. But if you didn't see that, your calculator will bail you out, so you get an error. So this right here, there is no solution on that. So that's why you're only getting those 2 answers. And again, that's the benefit of checking. See, I catch little mistakes that I make from time to time when I do that. So that means the answer to this problem would just be 0.8959 and 2.2457. So that is your final answer to this problem then. Okay? All right. So I'm going to have you go to the next problem. Just do this with the quadratic formula and see if you can do this one okay. I'll write down the quadratic formula for you if you need to. So it's negative b plus minus square root b squared minus 4ac over 2a. And again, it's a good idea to check your answer on your graphing calculator like I did the last one. Okay? Okay, so the solution you should have got was this. One answer, the quadrant 1 answer is 1.2996. Then you should have a quadrant 4 answer, which is 4.9836. All right, so if you want to look through what I did and see if you did okay, I just did the substitution like this. So I did p as cosine, and then that would mean that p squared would be cosine squared x. So you would get the equation p squared minus 4p plus 1 equals 0. And use the quadratic formula with a1, b negative 4, c1. Plug it into your formula, and you would get 4 plus or minus square root of 12 over 12 if you do the arithmetic. So I did this on my calculator. I did 4 plus root 12 over 2 and got this. 3.7321. I also did 4 minus root 12 over 2 and got this. So that means I got to do two things. I got to do cosine x, because remember, this is what p is, but p is cosine of x. That's why I'm doing cosine x equals 3.7321, and cosine x is 0.2679. So notice I did this on a calculator. If you do the inverse cosine of this, you get no solution. So that one doesn't get you anywhere. If you do this, you can see where I did this on my calculator, I get 1.2996 if I round that to 4 decimals. So the cosine is positive. See, this is a positive number right here. You were given a positive number. So the cosine's positive in quadrants 1 and quadrants 4. So that's what that reference angle stands for that came on the calculator. So your quadrant 1 answer is this. Your quadrant 2 answer, or 4, you would go all the way around the circle 2 pi minus the reference angle to get 4.9836. Now what I did on this, if you check on your calculator, this is basically what this is going to look like. I put in the function like this. The graph will come out like this, and then you just trace these two answers. So if I trace 1.2996, that's coming up pretty close to 0, so that's got to be right. Then if I trace the 4.9836, that also comes up. Okay, so that's right. Okay, so that is a long section. This textbook we have just puts so much stuff together in one section. It's a free textbook, which is cool and everything, but they sure could have spread this stuff out a little bit better, I think. So that's why I broke this up into so many pieces. So hopefully this helps you on this. You got to kind of categorize the different types of problems you do. There's a lot going on and a lot to learn here. This kind of teaches you how to do all of the different varieties of trig equation. All right, have fun, as always.